And 5.5, solving rational equations. So as we do with everything, we want to get to where we can take any type of function and solve with it as well on those. So that's where we're going to wrap up chapter 5 here for us today. Okay. So let's look here at our definition so that we pay attention to a few things. All right, it just is if A over B equals C over B. So if a fraction equals a fraction that has the same denominator, okay, then A must equal C. So if the denominators are the same, then the tops must by default be the same. So we want to use that to our advantage on those, okay? So let's look at examples and how to apply that to begin with here. And so we want to solve. All right, so number one, we've got 1 over 4 minus 5 over 6 equals 1 over A. 1 over A, okay? Now, one of the things that you do need to do before we do anything else is to determine the domain, because we can't have numbers that are going to create problems. So we got to know if our answer is a good answer, all right? So we want to check that and see, does it really work? So you can do this one of two ways with your answers. You can check the domain. You can tell me what the domain is going to be at the beginning. So my domain here, we take the one letter here on the bottom of that piece and we say A cannot be 0 in this case. And then we solve for A if we need to. You're going to see some later examples where I need to do that, all right? So that's one way to be able to check your answers. So if we get to the bottom and we get an answer that says A equals 0, we have to throw that away, okay? Because I'm saying A cannot be 0 for my domain. Now, another thing you can do once you get to the end of the problem is just to check your answers, take them, plug them back in and see if they get true statements. And if they do not, then we know that there are what we call extraneous solutions. They do not work for us, okay? All right, now, let's go through and get a common denominator here for these, all right? So the first thing that 4 and 6 go into is 12. Now you can use 24 if you would like. You're just going to have to reduce at the end. But our actual lowest common denominator is 12, and we need the A. So we need these all to be the same for those. So I'm going to multiply this one by 3A, this one here by 2A, and this one by 12. So now when I get those pieces, they're all 12A when we do that, okay? All right, so now we get 1 times 3A is 3A. Negative 5 times 2A is negative 10A, and that equals 12. Now we know all the bottoms are the same, so we don't need the bottoms anymore. Okay, that's the way this works. We are getting rid of the bottoms through this. Okay, so by making them all the same, no matter how many we have, we can get rid of them because we don't need them anymore per our definition. Well, now let's combine like terms. So I get a negative 7A equals 12. And then divide by negative 7. So A equals negative 12 over 7. That does not reduce. So that is our solution. Okay. Now, again, if you would like, take this answer, plug it in, and see if it works. And if it does, then you know you've done it correctly. Okay. But you've either got to check it by plugging it in, or you've got to tell me my domain in order to receive full credit to know that that is a possible answer. All right, so x over 3 minus x over 4 equals 12. All right, so again, I am going to check my domain here. I'm going to write that over to the side. Now this time I do not have any variables on the bottom. So that means my domain is all real numbers. I don't have any issues there. So we're good to go. Whatever answer we get, if we've done our math correctly, should be fine. All right, but I still have to get a common denominator. So I'm going to put that over 1. So again, a common denominator in this case is going to happen to be 12. So I'm going to multiply this one by 4, this one by 3, and this one by 12. And because the bottoms are the same, we don't need them anymore. So we're going to get 4x minus 3x equals 144. 4x minus 3x is 1x, so x equals 144. And that's not a problem because we do not have a domain issue for that one. Okay. All right, so let's continue. We're going to keep getting bigger and bigger problems, of course, because that's how we do things in math, right? All right, so we have x plus 8 over x equals -9. All right, so again, I'm going to look at the domain and see what's happening there with that. I'm just going to put this out to the side each time. So my domain here, I just have a single x on bottom, nothing else, because this is over 1 and that's over 1. So x is my only area, so x cannot be 0. So again, if I get 0 as an answer, I'm going to throw that thing out. All right, so I need these to be the same. This already has a 1, even though it's not shown. We can see the 1 there, so they all have a 1. But this one needs an x, and so does this one. All right, so now that the bottoms are all the same, I get x times x is x squared plus 8 equals a -9x. Now, since I have an x squared, that lets me know I have to solve using factoring and quadratics on those. So I'm going to move that -9 over. X squared plus 9x plus 8 equals 0. I'm going to factor this. So they're both the same and both plus. We get x and x. In order to get 9 from 8, we need to use 8 and 1, or 1 and 8. Now we use our solving rules. It says x plus 8 equals 0, x plus 1 equals 0. So that means x equals -8 or x equals -1. Neither which are problems because they're not 0. And so we get -8 and -1 for our solutions. We got 2 answers there in that case. And that's going to happen from time to time. So we have to look for it. We could get 1, 2. We could actually get no solution. It's all based on what the equation is, what's happening there. Okay. All right, number 4, 1/2 equals z minus 5 over z plus 1. All right, now there is a little shortcut on this one because it is a single fraction equals a single fraction. We've not had that so far, but only if we have a single fraction equals a single fraction, like I do up here, we can do what we call cross multiply. I'm going to take this 2 and multiply it up here, and I'm going to take all of this and multiply it up there. And that's going to get rid of the fraction. So over here, we're getting 1 times z plus 1 equals 2 times z minus 5. So I just pushed each one of those up on the other sides for that using cross multiplication. Now again, we can only do that if it's a single fraction times a single fraction. All right, well now we can distribute, so we get z plus 1 is 2z minus 10. Now, I know I'm part of the way through the problem, but I've already kind of thrown myself off because I didn't take the time and do my domain. You might have been noticing that. Mr. Jones, hey, you should have already done your domain. Let's go ahead and do that because I don't want to forget it any further now that I've thought about it. I can pause what I'm doing down here for this. Now for our domain, There's no z there, so I don't have to worry, but I've got z plus 1 here. So z plus 1 cannot be 0, so z cannot be -1. So we're going to be paying attention for that at the end. If I get -1 as an answer, I'm going to throw that out. So again, I apologize there for that. Moving a little too fast for myself. I know things are working and I can check at the end pretty quickly, but we always want to check those things. All right, so now I'm going to move that z over to the 2z. So 2z minus 1z is z. And I'm going to add this 10 to the 1 and get 11. And so that is my results with that. It's not -1, so we're good to go. Okay. Next one, 5. So y minus 1 over y minus 3 equals 2 over y minus 3. All right, let's go ahead and check that domain. So we're doing that. I've already made that mistake once, so I don't want to make it again of not checking that. So my domain here, but we know we have x minus 3 cannot be 0, so x cannot be 3. We have it again, so I don't need to work it twice, okay? If you have the same exact expression multiple times, you only need to do it the one time because we're going to get the same answer every time. So we don't need to do that, okay? All right, well, our denominators are already the same. That's awesome. So that means the top up there, let me get my other color marker out. So y minus 1 equals 2. We're going to add 1 over, so y equals 3. But we said y cannot be 3. Well, that's my only possible answer. We cannot use it, so there are no other answers. So this is a no solution, empty set for that one. Okay, so that happens occasionally for those. Right, moving on. Number 6 here. So 1/2 minus 4 over 9x equals 4 over 9 minus 1 over 6x for those. And I do recommend, you'll notice I left quite a bit of space in between those. I do recommend that just so that you give your spot a place to do some multiplication for those common denominators and be able to write things in there. So kind of keep that in mind. All right, so here I still need to look at my domain. I'm going to write it underneath this. 2 is not a problem. There's no x there. We've got our 9x. So 9x cannot be 0. So if we divide, x cannot be 0. 9, and then 6x is going to do the same thing, but I'm going to go ahead and write it out just so that y'all can see it with those. So they're both 0 in this case. So I still just am going to be looking for that 1 cannot be 0. Okay. All right, so now I need to get a common denominator. So the first number that 2, 9, and 6 all go into is 18. Okay, so I'm going to work with 18 here and x. So to get to 18x, this one needs a 9x. Get to 18x here, this one needs a 2. For this one needs a 2x. And then this one needs a 3. Now, if we multiply out all those bottoms, we're going to get 18x. So I don't need them anymore. So I'm looking at just the top. All right, so I'm going to get 9x minus 8 here and here. And then 8x minus 3. So now we solve. So I'm going to move the 8 over with the 9. So minus 8x gives me 1x. And then I'm going to add 8 to -3, and I'm going to get 5. 5 is not 0, so that is our solution. Okay. All right. One more problem here. for us to finish up. So number 7. It's going to be our longest and biggest problem, so bear with me here. 6 over x squared minus 4x plus 3 minus 1 over x minus 3 equals 1 over 4x minus 4. All right, now the first thing that we need to do is the common denominators. But if you remember, when we used to add and subtract these, we needed to factor if we could. First, we've not had that so far and had to worry about that, but we should always be looking for that factoring piece. So I see right here that I do have a quadratic, and also see I have something in common. Now you'll notice that I'm not looking at the domain yet. I do want to factor first before I look at the domain, and it's going to make our lives easier to do it that way. Okay, so let's factor first, then we'll look at the domain, then we'll complete the problem. Okay, all right, so we're going to get 6 over. We factor this, we get a trinomial. Both of them are minus, so x minus 1, x minus 3. All right, the minus 1 over, we get x minus 3, but we don't have anything else, equals 1 over, well, I can take a 4 out of that, and we'll get x minus 1. That's good because we have some similar pieces there on that, okay? Let me erase this real quick. Now let's look at the domain. So I'm going to write domain up here. We've got an x minus 1. So x minus 1 cannot be 0, so x cannot be 1. And there was another one down there, so I don't need to do it twice. And then I have an x minus 3. Cannot be 0, so x cannot be 3. So 1 and 3, those are problem areas for us. All right, so if we get either one of those answers, we're going to throw it out. Okay. Now, if we get other answers besides those, even if we get one of those, we get 2 answers. One of them we can throw, one we can keep if that's the case. Or we can keep all of them or throw all of them based on what it is. All right, so now I need to get common denominators. That has an x minus 1. This one does not. It's minus 1, not 4, 1. Okay, so now it has it, and so does this one. This one has an x minus 3. That one has an x minus 3. So the last one down here needs it. So those are good, but this one has a 4. So we need to put a 4 on these. This one needs a 4 and times 4. This one needs a 4 and so does this. So now they're all exactly the same. And the order doesn't matter. They have the same parentheses and the same numbers for those. Okay. All right. Now that the bottoms are all the same, we don't need them. I do want to be careful with my distribution. So 4 times 6 is 24. Negative 4 times 1 is a negative 4 times x minus 1 and equals 1 times x minus 3. I'm going to do my distribution in the next step here so that I'm not doing too much at once. All right, so 24, we're going to distribute that negative 4. So minus 4x plus 4. So I'm distributing here. And then 1 distributed in just gives me x minus 3. All right, we combine like terms. So I'm going to get 28 minus 4x equals x minus 3. I'm going to add this 4 to the x. So give me 5x. I'm going to add this 3 to the 28 to get 31. And then I'm going to divide. So x equals 31 over 5. That is neither 1 or 3. So that is my answer for those. Okay. And so getting that domain, we need to check it every time. It's a little bit easier to do a domain, but if you want, you can take this, plug it back into your original and see if it creates a 0 on the bottom for those. And that's another way of doing that. But you're going to have to show that your answer is a good answer and that it does not get in the way of the domain. Okay. And so that's how we're going to solve and work through these last problems.